I've started the recording now.
Sumith. Hello, Sumith. Venkat here.
Yeah, Venkat, tell me.
Yes, Sumit, I'm new joining. Just 2 weeks back only I joined. This is for me. It's the first time this meeting today. On your screen it shows this something like XKE attendees. There is a coupon code. What it is for? In fact, your black screen is shadowing it. There is a coupon code which is ending with 022. What is
Can you
this?
see your screen? Can you see your
Yeah,
screen now?
yeah, SKP XKE March 2022. What is this?
Actually, this is my first published book. So I'm just telling people if they want to kind of just go through the links and see what the book is all about. And
Okay.
if they like it, they can just buy it. That's the thing.
Oh, okay, okay, okay.
Can you see my
And
screen
these
now?
links, yeah, these links, can you please paste these links in chat box because I am unable to get.
Sure, sure. You can even use the QR code. The QR code
Yeah,
shown.
right. Even that also fine.
Yeah, I will do that. I got the
Yeah,
point. I'll do
thank
that.
you.
I will also
Yeah,
share.
yeah.
I will also share this entire PPT at the end of this session.
Sure, sure. Okay, yeah, okay. Thank you, Sumit. Yeah.
Thank you. Thank you. Yeah. Just give us. Let's give 2 more minutes for people. Just 2 more minutes. Let's see how
Okay,
many.
yeah.
So, hi everyone.
Hello.
No.
Hi, hi.
No.
So this session is by Sumith Puri on his book, or it is something related to Xavier's, kind of the initiatives on the microservices space, and relevant to that, what all we have here in this book.
Hey Sumit, you can start.
Yeah. I think we have waited enough. And this time we have about.
Someone is mute, so please. Actually, your voice is surrounding.
Can you guys hear me now clearly?
Yeah, sure.
Yes, Sumith. Yeah, please.
Okay, guys. Welcome all. Welcome everybody. This time I can see 106 participants. Last time at the peak we had about, I can say about 80 participants, and this is like a series of microservices. You can say presentations. This will more focus towards, you can say, thought leadership, architecture, decision making, and understanding. Like I would want, rather than the before we delve into implementation, because in the future series, in the future presentations in this series, we'll also have a kind of hands-on, kind of you can say reference implementation session. So what I want all the attendees, like people who are in the first session and now people who are in the second session, is to keep their like you can keep the mind open, understand like what are you have been doing in your projects currently, whether it is microservices, monolithic, service-oriented architecture, serverless. Just keep your mind open. Try to gather as much knowledge. Okay, what I'm sharing. Even though I want the session to be very interactive, we have time constraints. So what I will do is like last time, people attended my session last time. The same way, I will just continue. You can say like for about 15-20 minutes, and we'll have 3 sessions where we break out to interact so that we can kind of meet the time constraints. So that's the idea. And then we can exchange the thoughts, maybe some questions, queries, and we can basically it's a discussion forum rather than just being a one-way kind of push of information. We all have knowledge, we all have experience, we all have worked on various architectural paradigms. So the idea is to kind of share the knowledge and take the knowledge ahead. So that's the idea. Okay, so let's move ahead. Um, okay, so the first session, it was called as the pains of monolithic architecture. And this one is called as needs and motivations for microservices. Okay, and this entire series will be called as journey from monolithic to microservices. Okay, that's the idea of this XKE series. So this is part 2, session 2, and called as the needs and motivations for microservices. Okay. So the agenda here is that already people who attended session 1, they know that we have gone through the pains of monolithic architecture in terms of what are the, you can say, failures, disadvantages, shortcomings, and what we'll try to do in this session is to just very quickly, very briefly, just touch upon those and get into the depths of promise of microservice architecture. What are the promises of microservice architecture, and thereby deriving the needs and motivations for microservices. And microservices themselves have some challenges in their adoption. Like it's not so easy that we can just say we want to move microservices and we'll move. Okay, it might be, but in enterprise, in a complete business, we need to make sure that we know beforehand what are the challenges of adopting microservices. And in 2021, we just quickly see what is the percentage of companies or projects that are adopting microservices, and yeah, what are the companies that are working on monolithic, and then we kind of end the session. That's the idea. Okay, that's the agenda that we kind of want to cover in this 1 hour. Okay, so any of each one of us here, we will be working on a project which is any of these 4 which are listed here. Okay, I'm sure at this point in time, most of you might be on microservices, or very few of you might be on SOA. There might be a lot many on monolithic as well, and there'll be some on serverless. So I want you to visualize when I speak of these things, visualize in your mind, like what is the meaning of a monolithic architecture? Like we, in the last session, those who attended, we went through depths, like what exactly is tier, layer, n-tier architecture, 3-tier architectures. So monolithic architecture, rather than going through a definition, I would just say it is fine for small applications. It's fine for small resource base. Now, when I say this, it doesn't mean that it is the only way that we should only under these considerations we should use monolithic. We can use it under various other circumstances as well. But this is the guideline. If you say that a business, a company, small startup is there, they're building a small application, or there's some small code base, at that time we can immediately say we can go for monolithic architecture. Okay. Now, when we are in a kind of you can say um, uh, business which has got many systems. There might be legacy systems, there might be newer form microservices, there will be monolithic, there might be some other incoming integrations. So under these circumstances, when there are complex integrations involved, we would think of service-oriented architecture. Okay, like we can have some kind of bus mechanism for communication, and we'll say we'll use SOA. Now, microservices come into the picture when we have complex large-scale systems. Usually, most of enterprise systems fit into complex large-scale systems, and there are multiple skill teams. Skill teams that are geographically distributed. At that time, the first choice that we would suggest as architects or as organizations is that the customer or the business go for microservices. And serverless is the newer paradigm where we want to say that anything that is function as a service, backend as a service, or we want to leave the infrastructure management completely to some cloud operator or some cloud. That time we'll say we want to go for serverless. They'll be usually having much more greater client part. And yeah, any kind of if you say that you have long running tasks at the background, those kind of things qualify for serverless architectures. So what are these? I will not cover in this session because I've done this in the last session. I would request you to go to the recording. I'll share the recording in this Teams channel. You can see that and see what are these 4 paradigms. I will not cover it again. But I'm sure most of you have some idea. You have visualization of what is monolithic, what is SOA, what is microservices and what is serverless. So uh, I would very quickly skim through. Like I said, I will not cover the entire details. All of you know that if you are going to use a single block of components, whether it is like a desktop application, distributed, non-distributed, whether it's N tier or 3 tier, they qualify under the monolithic architecture. Okay, and you can just think of it as a centralized block, as the name suggests, monolith, and you can yeah, read more on this from the given link. Okay, I'll share this PPT to you. And service model architecture, like already mentioned, it is decentralized and there are loosely coupled interactions. Mostly they happen through something called as enterprise service bus. At this point, when the architecture journey evolved, we were having coarse-grained decentralization of components. So that is where the service-oriented architecture came to the picture. Okay, and when you went into fine-grained component development, fine-grained service development, that is where the paradigm of microservice architecture came to the world, and it requires it defines very good standards for, or very well-defined standards for infrastructural services, responsibilities, and it allows for independent scaling or selling of services to customers for any kind of organization. So that paradigm of having one block of application to a coarse-grained set of components has moved to a fine-grained set of components or services called as microservice architecture. Okay, and yeah, each of them have got their own advantages and disadvantages. And the last kind of session we had discussed on the pains of monolithic architecture, and this one we are just going to try to see what is the promise of microservices. Okay, okay. Now visualize you have to see the real world where you're working in various projects. Okay, for your customers, they might be in any part of the world, whether it's United States or Singapore or India itself. You will see that there are many teams. Okay, there that are focused on uh, various activities. Okay, now I'm not talking in terms of testing or development and all those, but geographically dispersed teams. There might be teams working geographically dispersed on the same problem, and they might be building components. Okay, but when we visualize this thing in a monolithic system, we see that we usually used to divide the development in terms of front end, back end, or we used to divide it in terms of feature. But what used to happen is that there might be localized localized teams or localized needs to develop specific skills, specific databases, specific tools. And it is always, I mean, even though we say that we are a global delivery model where people coordinate as a single team, it's always good to have people who can coordinate better in their own local geography rather than the global coordination. So considering all of these, an independent development paradigm where teams, even though they are geographically dispersed, they are working as a team, they need to work within their own silos as well, within their own pods as well. So that is where the promise of microservices came to the picture. Okay. What happens is that it allows the development teams to focus on their own specific components or services, irrespective of technology stack, irrespective of layering, they can work on their own database, and then they coordinate together through loosely coupled mechanisms. Um, and then that way there is much more faster development, better use of skill set, and you can say there might be common teams still. There might be teams that are working on common components, interaction mechanism, infrastructure services, but there'll be lesser coupling in terms of teams, in terms of the components, and that helps the quality, that helps the teams to work within their own time zones and carry on their independent development. So that is one promise of microservices and a shortcoming of monolithic development. When we say that, so the question might arise: is it really a shortcoming? Is it really a promise? Well, there are many more contexts to this, and we will cover it in the future sessions or in this session as well. So you have to understand. Uh, if you are working on monolithic right now and you have teams that are also dispersed, you might be facing many issues, which are time zone challenges, which are trying to coordinate for a feature, for a specific service, and then dividing work between each other. But if it was divided in terms of components between each other or services, that might be much better, and that might be more rational, and it gives more advantage to the customer for whom you're building the product, the end stakeholder, it gives them a better quality project, better quality outcome. So that is the one uh, shortcoming of monolithic, which was independent development of development and the promise of microservices. The next one was coupling. Now, see, when we talk of monolithic services, okay, I have not put too much of diagrams. Possibly diagrams would have helped you visualize better. So I would want you to visualize it in your mind that when we are talking of coupling, okay. Now, let's say we are building something that is like an accounting system or inventory management system. We'll have some order management, some inventory management, supplier management, customer management. Now, all of these actually are thought of as the residing on the same server. They are more coupled with each other via direct invocations. And even though we are going to use solid, OOPS, and all kind of architectural consideration, design kind of principles, we will still consider it to be tightly coupled. But with microservices, if you have to think of the same inventory management system, um, whether it is order, like whether it's order, the order management, the supplier management, the customer management, they'll all form different component, different services, and they are really loosely coupled. Okay. Now they are all in disparate servers. They can have their own database. Okay. Um, and shortcoming of monolithic. Okay. Um, that tighter coupling is removed by microservices because it brings a looser coupling. It allows people to teams to develop by themselves and be loosely coupled, and then integrate with others via some um, via some specified contracts, usually REST web services or possibly SOAP web services, whatever. So it allows them to integrate with various mechanisms. So one of the popular one is the REST kind of mechanism. So they carry on the development to good enough quality, good enough level, and then integrate with each other. So that way, it's a looser coupling based. It's a more loose coupling when we talk of microservices. Okay. So scalability. Now, in terms of scalability, this is what I had discussed in the last session as well. So you visualize the system again, which is like the same system: inventory management, order management, account management. Which means that I'm having one stock, a list of items which are in my stock. There's inventory. Somebody places the order, and the stock gets subtracted. Somebody raises a I purchase from somebody. I raise one order, and stock increases. So that way, an inventory management exists. Then there is some profile management, user management. Now, in this, the core activity of this inventory management will be ordering. Okay, like most of my CPU, most of my RAM, okay, most of business logic, and all of it will be used by these core services. Okay, so I do not require symmetric scalability. I cannot say that each of these services which I'm having, such as profile management, user management. A profile management, user management is hardly used. Possibly in a month's time, one time somebody goes and updates his profile, possibly. Okay, or maybe not even once it is kind of updated. So under such circumstance, these systems are usually marked by symmetric scalability. Like they just scale symmetrically, but usually systems require something called as asymmetric scalability. The core features and core business logic services, they have higher scalability requirements. They have stringent performance requirements, and they are the ones that make or break the business or make or break the systems. The user satisfaction depends on them. So with the advent of microservices, the greatest advantage, the very basis itself is that whether it's service level or database level, uh, we decide what is the size of the system. We allow to the sizing of the system. We allow to plan what is the kind of resource required for each particular need that we have. Like we can say that one is a large system or extra large system in terms of business logic, in terms of requirements. One is just a micro, like a small system, or a very small system. Like we can have our own sizing, or we can tie it up with the cloud mechanisms, and then we can just say that we can decide, we can have asymmetric scalability, and that is one greatest advantage. And database also will be independent for each of these services. Okay, and yeah, so it does introduce some challenges, like I said, all of these things, and that is something that we'll discuss either in this session or future session as we proceed. Okay. Now, scalability, when we talk, we also talk of availability. Okay. So these are all this EDT, like ILIT. Why? This when you note, these are something. the abilities of software architecture, okay, which means that they are the ones which a system architect or a has to define to make sure that the system is performant, is of quality. So this focus that we are doing now is based on all of these abilities of software architecture. Availability is the time that systems are available. Like you go and use a banking application. Like when sometimes you see that there are planned downtimes, or there are things where there will be unplanned downtimes. Like you see this example which I've given previously also, Flipkart Big Billion Days. What happens is that when like lakhs of users hit the application, we see that it has gone down. Like maybe 2 years or in a sequence, it has gone down. So under such circumstance, um, like we have to make sure that the system is highly available. That is, even though the load increases, okay, there is very high peak load, it has to still be available. Now with microservices, uh, even though this kind of whatever situation I explained still exists, okay, but we might be more fault tolerant. Will be better equipped for failure recovery, retry and fail mechanisms, and will be better equipped for peak loads. Like we can say, parts of the system can fail gracefully because we are in Microsoft architecture. Each of the services are independent. So let's say, for example, the core service goes down. Like when I was ordering an e-commerce system, the core service went down, which is the ordering mechanism, and it starts failing gracefully. The entire site does not come down. So there is a site which runs the e-commerce site. It shows everything, it shows the product, and somewhere when you order that, it says that due to technical snag or due to peak loads, we are not able to currently, but we'll be back soon. So those kind of graceful messages can exist, and there are ways to handle it like more efficiently through various scaling mechanisms. So that is where this availability thing is better handled by the promise of microservices architecture, like the microservices architecture. Okay, promise of microservices simply means advantage of microservices, or with microservice architecture coming in, what is that advantage it holds for us? Okay, so performance. So scalability is more like a, you can say, a total term in totality. Performance is like a single, you can say, a single localized or single API based notion. Okay, when I'm just saying that the performance of system is currently very slow. It might be per user that somebody says that, another person says no, it's fine. So with microservices, generally with every service having its own database, its own resources, RAM and CPU, it is bound to increase the performance. It will reduce the response times, and it is bound to perform much higher than monolithic counterpart. Okay, even though both are related, they are not exactly the same. The performance and scalability part. So that is what the advantage um, the microservice brings in. Okay. Um, then the infrastructure. Now, what happens with monolithic system? Okay. Now, when I'm when I spoke of all of these things, you would have visualized the various, you can say, ability software architecture. The infrastructure comes like the physical, you can say the activities or the physical abilities that are in terms of providing security, providing retry, providing service health, service discovery, configuration management, log analysis, logging, things like providing report and service availability. So all of these things in multi systems, even though they existed, we used to build it ourselves. Or we used to use external systems. They were not too much well defined. Okay, but with microservices, there's a standardized blueprint. Like if you go to a site called microservices.io or a Microsoft site or the IBM site, you will find standardized microservice infrastructure blueprint. So they give a blueprint saying that organizations who want to use microservice architecture, they have to use these set of components to say that they're certified for microservices. Okay, there might be things like service discovery, circuit breaker, config server. So many things like this. There are various kind of architectural concerns, infrastructure concerns, and there are various makes of these products that you can consider for your own project. So so that way, it's a promise that rather than having standards that are haphazard, now we have standardized way to look at the microservice infrastructure, which is very well defined, and you can try to adhere to those standards as far as possible, as far as required. Okay. Business. Now, when I say business, ideally for a bank, the business is basically getting customers, opening more accounts, or whatever. If they're in credit cards, selling more credit cards, getting more customers. So, yeah, if it's e-commerce, then selling more products. In every way, it's getting more customers becomes the final case for the business. Okay. Now, usually, whenever earlier in monolithic architecture, if the business says I want a new feature or a like uh, I'm going to I'm going to get ahead with the new kind of feature for business along with credit cards. I'm offering insurance. Let's say it was the case. So the development teams will have to go and build this, understand this, and incorporate into monolithic architecture. That business to engineering bridge that was far greater. It's more complicated because it's more tightly coupled. There's no independent development, forming those teams, understanding requirements and building would be, or you can say will take more time than a microservice architecture because here we can form independent teams. They build by themselves, understand by themselves, build their own database, and just integrate with services that are available to them in whether it's in the given ecosystem or in the ecosystem outside. And that way, uh, businesses can scale their business faster, can build their business faster, can provide services faster, and yeah, so that's the one important advantage of having like a microservice architecture for business. Okay, so like when we quickly look at these, uh, sorry, when we quickly look at these advantages, and on a quick reference, you can say chart kind of thing. There is a independent development teams, better performance, okay, and loose coupling, the availability, scalability, infrastructure, and business. Okay. So I would want you to, I mean, because there's a lot of information here, I would share this PPT with you, but I would want you to visualize each of these things from your current projects, from your past projects, and yeah, I think we are almost like halfway in terms of time. So let us throw it open for the next 5 to 10 minutes, and people can kind of share their, uh, you can say, what was the thought process in terms of either some success stories, microservices in their projects, or if there are queries, we can you can put ahead the queries and anything that which is in terms of monolithic microservices, this is SOA or serverless, and yeah, it'll be which is good for this forum for all of us. I would want you to kind of use the next 5 to 10 minutes for this activity. Yeah, guys, it might be just on some great success story in your project, or like maybe you spend some 1 or 2 years in a project and then move from monolith to microservices, and what challenge you face in the real world while adopting microservices. Maybe you can share that to us, or gently open up, throw up any query to in this forum here.
So are we going to have it verbal or something in the chat we can put or
Maybe
place?
verbal is fine. If you find it's too tough, then I will take it up. Like we can start pasting it
Okay.
on the chat, and then we will just take it offline.
Yes, Sumit, you spoke means quite a lot of say relevant things of microservices. But what I feel, being a microservices enterprise architect since last 5+ years or since its inception. So what is very, very important is the ecosystem of the microservices. NFR, fine. Okay, although the scalability kind of the things are now easy and means relatively means you can say quick, just in time or whatever, or pay as you go, or all those kind of the things which the service providers and vendors are providing that kind of ecosystem, whether it EKS, AKS, and ARO and all those kind of the clusters and kind of the Kubernetes environments. But what I thought that should be covered in the beginning itself is domain-driven design, event-driven architectures. Then what is kind of event storming by which we are quickly able to figure out what all candidate microservices will be there as a part of this particular enterprise or this particular ecosystem. Then the communications across the microservices, which are the key things, because the communication across the microservices is definitely a challenge, eventual consistency, saga, and all those kind of the patterns. Then when we are basically going through the transformation journey from the monolithic to microservices, because people don't dare, or people don't have basically that kind of, you mentioned business paradigm as well as the kind of the strategy and vision of the organizations. But what I feel, what is very important is most of the microservices based kind of the developments are happening for the sake of digital transformation, or to compete with, I would say, the industry standards, as well as the kind of disruptors which are evolving. Automation is there, artificial intelligence is there. Because of all those things, people are migrating their monolithic applications to microservices based kind of the ecosystem. So what is the say roadmap, or what is a good roadmap for those kind of digital transformations? So a high level kind of the description of all these kind of the ambitions, as well as kind of objectives and goals of microservices, rather than scalability and then availability and those kind of the, yes, they are definitely some vital parts and vital kind of motivations of microservices. But what I feel is very, very important is that it's not all those kind of the factors. The factors are how we are going to basically have distributed kind of the systems, then multi-cloud environments, then hybrid cloud environments, then multi-partner systems. Not only all those things, we are going to have the services these days, how we are going to monetize that, how we are going to put it in the marketplace so that our microservices kind of services are available to anyone as an open API, or as a kind of the standard on industry API. Anybody can use my API endpoint and then integrate all those kind of the stuff with their kind of the upcoming systems. So all those things are kind of introduction, as well as kind of comparison. So definitely would give us very because this is architectural. You mentioned in the beginning that this is microservices architecture. So that kind of the ecosystem should first I think give us sort of insight about all kind of the ecosystems, environments, and the industrial kind of the I would say challenges and all. And after that, give a very or rather say low level kind of the details that you included, that okay, NFRs and all, and how we are going to get the benefits and so on. So that is what, or that is where I was expecting, and I was thinking that probably maybe it is there inside the book, but I haven't seen your book. But definitely in the beginning of your introduction, basically I was expecting these kind of words.
Sure, Shagan. Thanks. That's quite a in-depth, you can say, analysis or a kind of, you can say, um, the kind of suggestions that Shahjahan has given. So basically, this series, like to put everybody in perspective, also Shahjahan, it's very bare basics, but it's in terms of a different journey kind of thing. Like what is more, see, all of already in the year 2022, most of you would be working on microservices possibly for the last 1, 2, 3 years. If not, when we are joining this discussion, when you're joining this XKE, the idea is that what was the pains, like the first session that we covered, because it is series, it's not like other XKE sessions, it's a series. I would request that if people like the session, they continue attending all the parts of the series. So in the first kind of series, sorry, first session of the series, we covered the exact thing what Shahjahan had mentioned in terms of uh, the the kind of pains of monolithic architecture. We explained what is monolithic architecture. We explained what is microservices and the bare basics like why it exists, what is the kind of meaning of each of them. And then in this session, the idea was to say what are the needs and motivation in more depth, rather than just explaining what it is. We want to go in more depth. Now, the next session, like whatever Shahjahan mentioned, we will be covering the microservice architecture in terms of I'm sorry, I'm forgetting the topic myself. Let me just quickly check. The next topic would be called as the moving from monolith to microservices. So next session, which will happen possibly in April. So in that, I'm going to cover whatever Shahjahan mentioned. I'll be covering the idea of moving from monolith to microservices in the way of understanding the existing monolithic architecture. What are the kind of candidates that you can move to the monolithic architecture? How to identify them, and what are the kind of once you identify them, uh, what is the way to meet some kind of Microsoft standard in terms of the basics Microsoft standard, and if there's any reference implementation for the my all my kind of sessions would be on biased towards Java J2E Spring Boot because I'm from the Java J2E world. So I'll be sharing the kind of links, and the fourth session will actually develop the together in 1 hour. We'll try to develop the minimal microservice infrastructure and try to in the session itself we'll try to run a microservices kind of service. At least 2 to 3 microservices we'll try to run using the microservice infrastructure that we build. So that's the agenda of this series of sessions. And towards the end, one last session we'll have on what is the overall now, because we would have gone through the entire journey. Finally, we identify in depth what are the challenges of this microservice architecture, like what are the failures. Because already there are a few companies who are even moving on to microservices. There are case studies on the internet. So that is the idea. But what Shahjahan said, few of the things we covered in has been covered in one and will be covered in three. This one is for the needs and motivations, and few other things. I think basically, if you're talking about some um, I would think that is not basic. That would fall into the discussion where there are possibly just software architects or people who are having too much focus on industry, deciding about like hybrid clouds or possibly specific cloud usages. So I think I would not include that in this series. But rest of the things, what you said, almost 70 to 75 percentage, I think everything would be included in the series of these sessions. That is the tone of this whatever like I'm taking it in these XK sessions. That's the tone.
Thanks, Sumit. Thank you so much. Yeah. Okay.
Yeah, other guys, you want to share something? Any of the other guys? Some of your case studies or
Hi, Sumit. Hello.
Please
go Hello.
yeah, go ahead.
Yeah,
Please go ahead.
yeah. I would like to know what are the disadvantages of the microservices. So, and then the other part I would be looking is there any server or any, that means where if you want to try out a practical, is there any possibility for setting up server and giving the credentials for us so that we'll have a practical knowledge on the microservices? If anything such, please share with us.
Yeah, Jampani, are you on Java J2E or something, some other stack?
Mine is Java J2E Spring Services, Spring Boot.
Okay, fine, fine. So in your case, lucky because I have the see session number 4 is completely in that session. We'll develop the Microsoft infrastructure. We'll try to do it in 1 hour, like very, very fast, and we'll try to develop Microsoft in that session. But the code base, like anything that I want Git, can you, if you just ping me, like any of you who have that, because in this current group, I don't want to put in all those things right away. But if there's somebody like Jampani, Deva Prasad says that I want this, so I will share it with him. There is something which is already available. I will try to share it with you, and where you can go and play around with it, and you can deploy it locally, like on a local system, and just play around with it. Or if you're like, if you have AWS, some free tier AWS, you play around in AWS. It's your wish. So that I'll share it with you. Jampani, I'll share it with you offline.
Okay, sure, thank you. And then I would like to know what is the disadvantage of microservices? So we are having many microservices, Sumit. So this there is a chaining of microservices also is happening. So whenever a request is coming, the traversal time is taking more time. So how do we reduce that?
Well, there is one entire okay. Now to answer it in this, this for the answer is complete. One session is there which is pointing towards the how to handle or what are the failures, like how what is the specific point of failures of microservices. That is session number C1. Now this 2, 3, number 3 is the like I already mentioned to you. The session number 3 is going to be called as moving from monolith to microservices, and session number 4 is the building the RI. Session number 5 is called the failures of Microsoft architecture. So with 5 sessions, I will end this XK series. So that time I would want to cover it. But when you are asking this question now very quickly, it's like each of these advantages that we mentioned, like each of the advantages that we mentioned for this Microsoft infrastructure also become a pain point for us. What happens is that now visualize that we used in monolithic, we had a database. Now we are having multiple databases. So how are we going to take care of data management? Okay. How are we going to provide data consistency? What about how are we going to make sure transactions are maintained. Okay, how are you going to manage transactions? Now, when you said chaining of microservices, uh, yeah, possibly when that happens, how are we going to use event-driven systems correctly? Okay, and then all these things. What design patterns are we going to select at that time? Whether we are going to use Saga, whether we are going to use CQRS, whether we are going to use event sourcing. There are many technologies also, state machines. So how we are going to handle that uh, is the topic that has to be decided on a per project basis. Okay. In a simple way, there is no. I cannot say that for the X question answer is Y. I can only we can only discuss about subjectively of each problem at hand. There might be architects in your team. There might be customer architects. There might be other senior professionals, senior engineers. So that people have to get together and like based on the experience, based on the specific needs, we decide what exactly has to be done. So that is the best answer I can give.
Yeah. One more thing, Sumit. Can you please share the best practices for microservices? Best practices.
Yeah, that I can. I will share it to you. I
Okay.
will I will provide you. It will see that the 12 factor Microsoft principle usually does not apply to my. If people are not aware of that, there's something called as 12 factor Microsoft principle. Now that 12 factor Microsoft principle is actually 12 factor cloud native principle. They are not Microsoft principles. So they are not as it is applicable. Okay, not entire software industry or people say that they are 12 factor Microsoft principles. They are used for cloud native applications. So there is variant of that, and that is usually it might be 8 factor or whatever like various authors have provided their inputs. So I will share it with you. The two things. One is the reference implementation in Java J2 is Spring Boot, and the second thing is the best practices. I'll share it with you, Jampani. And to the entire forum, I'll share it if it is required. If something makes sense to the entire forum, I'll share it on the Teams channel.
Okay, Sumit. Thank you.
Okay, so without wasting more time, we'll have one more last query round before we let's move to the um, okay. So
Hi, this is Ajay.
yeah,
I had one query that comparing monolithic with microservices. Uh, I mean, there are lots of differences between both, but this service-oriented architecture and microservices architecture, my understanding is they are pretty much close. But in
yeah,
terms of deployment, this SOA applications deployment is, it is not independent.
yeah.
So
See, with the advent of in between these two, the original definition of SOA with the advent of microservices has changed now. Okay, but in the original SOA, like the intention when it was created, we had separate systems. For example, you think that a bank had one system um, for transaction processing, like batch transaction processing, and one a bank had a web-facing internet application. Now, and then it had got some legacy analytics systems. So all of these integrating them together via SOA through enterprise service bus, loosely coupling them. That was the
yes,
idea why SOA came to the picture. Now, with time going ahead, basically both are SOS implementation factor becomes microservices. So that is the differences are decreasing to great levels. They are not different. You can say they're not much different anymore.
yes, because this ESB has it has been like the messaging is implemented through Kafka in
Yes,
microservices.
yes, yes.
So yeah, it's pretty much same.
Right. As time proceeds, it's you can say microservice becomes the implementation technology or implementation thought process for SOA, that kind of thing.
Yeah, yeah, that's right.
Okay, so let's quickly, yeah, please go ahead.
Hi, so this, for microservices, how do we provide, myself, Naresh, sorry, how do we provide the security layer for the microservices?
Okay,
Where
usually,
exactly we can provide it?
yeah, usually it is done through multiple mechanisms. Like one of the popular thing is we use See, I'll give you a few terms. There are JWT, and then there is Spring Vault Service. There is Vault Service, JWT, VPC peering. So there is system-based authentication, there is user-based authentication, and then there are things like, uh, yeah, this is primarily things like how to maintain. One is the identity of the user, and then things in the cloud, basically saying that whether you can really access me or not as as a given service. So all those things, ideally, you can say that it falls like if you have a centralized component like an API gateway for a system in terms of lower level architecture, and then we first of all authenticate the user, and then we give him a credential. The credential is valid to be used in his journey for that microservice like invocation during that time. So that kind of thing. Either it can be time bound for that particular invocation, or time bound across his login in that system. So that kind of thing. And then we have VPC peering for the system authentication, just making sure that you can access the system. And in that same token, there are variants of that token JWT or another token certificate mechanisms where you can say whether he's allowed to access a given service or not. So that is like in my current project, we are using a token which allows the one is the one is authentication. One is whether he's in the same token. We can deduce whether he's allowed to perform that whether he's allowed to access that service or not. So that is how they have encrypted that. Uh, they've used a variant of JWT.
Yeah, okay.
Okay, so what are the challenge? So we have 13 minutes left scheduled time. Mein. So the challenges of Microsoft architecture. Okay, so you people keep your mind open for challenges, because many of us spoke about challenges. Like we want to know what are the challenges. So the overhead. Basically, overhead means that if we talked about standardized infrastructure and mechanisms. Now, if you have to adhere to standard infrastructure mechanisms, that definitely comes an overhead. That we have to make sure that we are adhering to that standards. We have the current health monitoring systems. We have the current API gateway systems, we have circuit breakers, whatever. We can do it without that, but then we would not adhere to standards. So overhead is one of the challenge. High skill. Now this is like a very theory kind of topic, high skill, but definitely microservices. You can say that in terms of making it successful, it is not something like you just go and develop a service independently and become microservice. There are a lot of challenges to it, and to make it successful, we can definitely say whether it's an architect or it's an engineer or developer, we require some higher skill than a normal monolithic architecture. Complexity. Now, for DevOps teams, so first one overhead was for, you can say, for the business or for the architecture. High skills for architecture and development teams for business. Complexity is again for DevOps and for the entire organization, because many microservices. If you go and just go to Google search and says Uber's microservices infrastructure or Uber's Microsoft dependency map, you'll get like a galaxy kind of image. It looked like a galaxy. I would want to share that, but I'll not share it. I'll share it possibly in the future sessions. It looks like a galaxy. There are so many microservices, possibly tens of thousands, and the complexity is very high to maintain them. Okay. Now, redundancy. So what happens is that when teams are developing independently in independent silos, they usually end up duplicating code, and we have to make sure they don't duplicate functionality. But many a times these teams might duplicate code to good extent. So we have to make sure that discipline is followed, that the code and configuration which should not be duplicated, and that is the only way to solve the redundancy problem in Microsoft architecture. Data duplication. So the same complexity factor which is there here, redundancy, when it moves to data, it is data duplication. So how much database, like let's say we are having 5 microservices. Earlier, these 5 microservices monolith had only one database, or they had a cluster of database. Now they have their own database, and they have their own database cluster. So how are you going to make sure that the data duplication problem, okay, is handled? At least we have to minimize the uh, data duplication that exists, and there should be a correct single version of truth. Single version of truth means I need to know where exactly to go to fetch the correct version of the entity. So this needs to be planned, architected, and infused into the design. So communication. Okay, so event, somebody mentioned about event driven, and then messaging based systems, event driven systems. So how are we going to make sure that microservices are able to communicate with each other? And there is a newer paradigm called as service bus. Okay, it's called as the service mesh. Okay, and yeah, sidecar based patterns. And so how are this communication becomes an overhead and challenge in Microsoft architecture, because we have to make sure that it is not down by itself, it does not fail, and if there is failure, there is failure recovery and failure handling. So that is one of the challenge of Microsoft's infrastructure. Okay, now the maintenance. Now, maintenance means all of the points which I mentioned earlier. In terms of a business, they have to pay to cloud DevOps engineers, they have to pay for cloud, they have to have more expenditure on hardware, they might have to have more expenditure on software in terms of monitoring the health. And so this entire thing might be complicated process, and the maintenance costs are much higher for microservices than for a monolithic architecture. So these are the important points. I will once I share with you, you also go through it. Just think about it, the overhead, the high skill, complexity, redundancy, data duplication, and communication and maintenance. Okay. Now, what is the kind of internal microservices? What are the related things that have gone ahead in this world? Like in terms of, you can say, in the ecosystem, there are true cloud apps. True cloud apps mean native apps, native cloud apps, and containerization. Now, with see, it's not necessary that we have to have only microservices in the cloud. We can have monolithic, we can have whatever kind of things in the cloud. But with microservice microservice adoption, the native cloud application adoption has become much greater, much higher. The combination of cloud and containerization, that is AWS, GCP, Azure, or Docker, Kubernetes, we're able to form those independent components much easier, much faster, much reliable. Okay, and it is easier for us to push those updates. It's easier for us to for DevOps teams to provide reliable updates, more error free. So both of all the things which are microservices and container and cloud, they are mostly gone hand in hand, and that is what these slides want to mention, that we like almost 50% of the applications which are now built are using microservices, and it allows the more fast adoption of cloud and fast adoption of the containerization. Okay, so that is one point, that these three things always mostly go hand in hand: microservices and containerization and cloud. Yeah. So Docker Kubernetes is the most kind of gold standard for enterprise software. Okay, and yeah, the 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 idea of pushing the updates, versioning updates, and maintaining the updates, maintaining the versions is much easier, much closer to microservices. And yeah, so these three have gone hand in hand in the modern day. All these technologies have evolved together. Okay, so once we talk of this, we will talk of the final kind of thing. The sound you heard is to signify that Microservices is a champion in terms of adoption by customers by any domain, whether it is logistics, whether it is banking, whether it is insurance or whatever. They all the companies want to adopt Microsoft architecture. And in 2021, that is one just in the last year, 49% want to start off any new project in microservices. 42% is still monolithic, 29% is SOA, and then remaining strategies which exist. Okay, so basically that 42% still shows that there are projects which are there which are built on monolithic architecture as well. They're being started on monolithic as well. Okay, there are companies, okay, just because of sake of maintenance, because of sake of the kind of tools and technologies, or the in terms of DevOps, in terms of the see that the ones which are advantages, they become disadvantages because of the kind of maintenance hell which they provide in terms of microservices. So they have decided to move to monolith for a few of their applications. Okay, there are case studies. That case studies I can share it to you. You can also find it on internet. You just type the failures of microservices, failure case studies of microservices. You'll find big names, big banks, and big companies who have moved back few of the projects from microservices back to monolithic, or they have tried to. At the end decision is that hybrid is the right choice, where we have part of it on monolithic architecture and then part on the microservices, just so that the maintenance hell, the complications become much lesser. Um, so that is what I want to bring into your mind, that there is 49% microservices and 42% monolith. And yeah, so this kind of presentation which I did now is primarily to put you in, you can say, in terms of visualization, in terms of thoughts, in terms of what a project you're working. You try to relate those projects which you're working right now to each of these parameters here. Okay, even though these are, you can say, for me, I would say they're basic, but still at the basic, you have to think through it completely to relate it with your current situation, and then see if you're already using microservices, you might know all of these and much more. Okay, like few of you shared here, you have good experience with microservices, you have shared few of things, and few of you might be able to relate it to current architecture, and you might be able to go back and suggest these things to who are your stakeholders, saying that these are advantages microservices bring to us, and how about moving to it, and also caution them if they do not know about the disadvantages. So that's the kind of, and then you can decide, like you will weigh what is right for a project. You can tailor it. You can use hybrid, or like whatever strategy that an organization comes up for itself based on these parameters. The most important thing is that it's not just simply we go and say Microsoft is the new kid on the block, the jazzy thing, and we adopt it. You have to correctly identify the reasons, and you have to chart out the path, and then move ahead with the microservice architecture. At the same time, you may also decide that it is not necessary for my grade of application, which is not very complex. It is like a, you can say, mid complex application. I just say that I am very easily able to scale using my current architecture, monolithic architectures, and I'm able to use clusters or whatever mechanisms. I use the cloud and I use container, and I'm fine with it. I don't need microservices, and that is also fine. So that weighing of those options, these thoughts are going to equip you to weigh those options. Okay, the greater your experience level, it will be more faster for you because you've got a lot of experience with you. You can relate to each of these abilities of software architecture much faster, and others as well. I mean, at whatever experience level you have, at least you can think through before you say, yeah, yes, I'm going to use microservices for my project, or my customer said, yeah, we are going to use microservices for a part of it. So whatever it is, whether you're going to use hybrid, whether you're going to use microservices or monolithic, you have to keep those options, weigh those options, and take the final decision. Okay, and I think in the end, most of project sizes would agree that we can use the hybrid variety. Keep the non-trivial, non-important services on monolith, and take the core ones, important ones, and put them into microservice architecture. And there also you might decide that it is not important that all of my core services go into microservices. Maybe only 50% is fine. And so things I am fine with a different variety. I take those and put into a monolith, like combine those things in a mold. So that's a decision which has to be taken on a per project, per need basis. And yeah, I think that is all I have for this session. And we have 1 minute left for scheduled time. Basically, again, let's just take 3-4 minutes more, and we can open up for people's thoughts and um, anything that they want to share in terms of their own experience in projects. Please go ahead.
Hi, Sumit. My Prashant,
Yeah,
basically, I have a question.
voice is not clear.
Okay. Am I audible now?
Yeah. It's better now. Yeah.
Yeah. So I had a
Can you,
question
can you
related
introduce yourself?
to separate DBs.
Can you introduce yourself?
Yes, I'm Prashansa. I have recently joined Xavier. And for this microservice architecture, I have a question. Basically, for each microservice, we are connecting to a separate DB.
Right.
Okay. And when it comes to cost, it would be so huge.
Yes.
Also,
Right.
when for the performance perspective as well, if I have to contact to multiple tables and I have to get the data, it would be very easy. If I talk about the monolith, I can have these data in a single database. I can simply write a procedure, I can get the data within seconds. But when it comes to microservice, and if my data is distributed within multiple DBs, to collate all this data and to perform the operation, that would be like huge. So how basically we can improve this in microservice? Or maybe my understanding is
Yeah. I mean, that's one of the that is the kind of issue that we come back to always, the data management. Okay.
okay, yeah,
What happens is that we have to use event-driven architectures. We have to use things like there are various design patterns which are there. And this like let's say Microservice 1, Microservice 2, they have their own databases. In first of all, the transaction mechanism. See, now the concept of transaction monolith was just straightforward. You either commit or roll back. That is the idea. But now we have to talk about things which are orchestration, choreography. I mean, we have to talk about event-driven architectures. We have to talk about things
Yeah.
where we are trying to get these transactions in sync or get this into one single transaction. Now, answering your question, um, you, we can do it in various ways. Okay, we can do it in um, okay. Let's say let's say business use. There is a business use case. Okay, I'll give you one simple example. Business use case.
Mm.
Now, business use cases in you think of the entire problem like monolithic architecture when it was there. I used to receive 1,000 requests for inventory management. I used to receive some 5,000 requests for order management. Okay, in one application. So what I did, I moved out inventory management and order management to different microservices, and I moved the other things like profile management, user management to a different monolithic based kind of hybrid service. Okay, now, what is going to happen now? The inventory management by itself talks to its own database. Okay, its own database. So that way, at least I gain the advantage of having the independent scalability. Okay. Now the question which you are asking, if I have to apply that on order management depends upon order management tables. It depends on inventory management tables. Now, when this thing happens, how I'm going to make sure where is the performance gain? Okay. Now, the design patterns that we use, the orchestration mechanisms that we use, I can say that if we if you have to if you're going to use any of the modern day design management data management patterns, I can say that for the larger part of it, yes, we can think of strategies. Either it is business use case based, or it is technical in nature in terms of implementation. We would definitely achieve more for a correctly well designed system. Okay, we will achieve more performance than a monolithic architecture. But the complexities, because see, when something fails, the failure recovery, there might be such cases that you never thought of while designing a system. Okay, it might be due to environments, it might be due to business use case. So if we are going to handle all those things, definitely the microservice architecture paradigm of doing these asynchronous updates is going to yield more performance than a monolithic counterpart. That is the answer that I have.
Yeah, just to add to that, Sumit,
Yeah.
uh, we can use in-memory databases also because all the microservices don't require their, isolated, kind of the databases. Some of the microservices are doing some kind of the tasks which don't require any kind of transaction into their own databases. So sometimes they retain it for some time and then finally the transactions are made in system of records or say in some permanent, you can say persistent environment. So I would say that yes, it's a combination. You need not have separate databases, but yes, you can have a single database server with multiple schemas. So if there are say 10 microservices, all those 10 microservices can be run in a single database server with 10 schemas. So one thing. Second thing, some of the microservices don't at all require any databases. They can use some in-memory kind of the database, Redis and all. Third thing is that it all depends upon how you are going to achieve single responsibility kind of the things, then independently deployable kind of the bounded context, microservices. So those are all architectural kind of the patterns and depends upon your, business domain expertise and so on. So I would say, yes, these are all distributed kind of the, applications. Microservices are all distributed, and how many microservices we are going to have in a co-located kind of the environment or a single cluster, or they are going to be in different clusters and so on. So it's all design concept. But the thing is that to decompose a bigger relational database into microservices database is a challenge, but there are lots of advantages. When we used to commit in a database and so many tables are related, there are 20 tables which are related, and how difficult it was to basically make a commit. So all those things are now, eliminated, and we are having key and value kind of the databases these days. So we can use a combination of relational as well as NoSQL databases and in-memory databases, which are again key value kind of the thing. So they all provide us an ecosystem in which we are quite flexible, and it all depends upon the kind of the implementation that we are going to achieve. So I think microservices database is not a complexity, rather it is an opportunity for us to manage and maintain those previous or monolithic complexities that we used to face in the past. A small change and impacting, say, hundreds of tables, 50 tables or 10 tables, and it is difficult to trace out the bug and all those kind of stuff. So that is the idea behind that, why it is better to have a decomposed databases.
Thanks, Shahjahan. So yeah, questions are like what Shahjahan mentioned, the data management patterns. It's not necessarily like there is something called database per service. You can have shared database as well. And yes, like Shahjahan just pointed out, it is sometimes that Microsoft very rarely, but it does happen in enterprise software architecture. There might be things which are very CPU heavy, RAM heavy, and they don't require a database at all. And we put them to Microsoft architecture just for the sake that they are heavy on logic processing. So all of these I mean cases like when we point out. So overall, definitely the Microsoft architecture, when designed in a correctly designed system, will win over its monolithic counterpart in terms of performance. Yeah.
Yeah. Thank you so much.
Thanks,
Thank you.
thanks, guys. So it's 5-6. I would want to take many more questions from you. Can you please directly send it to me? I would cannot take more time because it's a scheduled time that we have 1 hour. We have taken 5 minutes extra. So I would request that I'm going to share this PPT with you. I will also share the PPT of the first session in this itself, in this channel itself, and recording will be there. I would request for the questions on microservices. You can directly, if you find that you won't directly send it to me, send it directly to me or put it in this channel, in the common channel. And then I will decide if things require to be, I will decide that if it requires to be in the common channel, I will put it in the common channel or I'll directly reply to you. And if you people think that, if you find that there is something that useful you want to share by yourself, like in terms of some a link or some book or whatever, like you have some important thing to share, just once point it to me and I'll just put either me or you can put it back to you, the common channel. Okay. I mean, or you can put it by yourself as well. I mean, it's not a. I just want to make sure that we both concur that the tone of this serious session is maintained. Okay. In any case, I hope that you gained some, at least if 1% knowledge you had gained in terms of thought process, in terms of your understanding of these various architectures and primarily Microsoft architecture. I think the session's purpose will be solved, and we will continue this dialogue discussions offline on Teams. And yeah, you guys have a great evening. Thank you.
Thanks, everyone.
Thank you.
Thanks, Sumit. Thank you.
Thank you.
Thank you.
Thank you.
Thanks so much.
Sumit. Thank you. Bye-bye.
Bye.
Thank you.
Thank you.
Thank you, Sumit.
Thank you.
Thanks. Thanks, Sumit.
Thank you, Sumit.
Thank you guys. Thank you everybody.